Unit 4, Section 5. We're going to be proving that triangles are congruent. Now, we're going to do proofs a little differently. We're going to assume all of these. Then we're not going to prove the proofs like I did back in the 1900s. I actually had to prove that the proof proved the proof. And we're not going to do that. You're just going to take what I say proves it, and then you're going to use that to prove it. So, there are ways to prove a triangle congruent, and there are ways that you cannot use. So this is a reference sheet here. So you will refer to this a lot, thus reference, refer. But ways that you can prove triangles are congruent. SSS, side, side, side. 3 parts of congruent, or 3 pairs of congruent sides. So that'd be like this, undo, need my pen. I always forget the pen. This side is congruent to that side. This side is congruent to that side. This side is congruent to that side. Side, side, side. If you know all of the sides are congruent, if they have 3 congruent pairs of sides, you're good. SAS, side angle side. If you have a side sandwiched around an angle and another side, so you can say like this side and that side, this angle and that angle, this side and that side. That's SAS. That's the side angle side, because you got a side, an angle, and a side. A side, an angle, and a side. They have to be the matching pieces. You can do angle, side, angle. You can do an angle sandwich. Well, I guess a side sandwich and an angle sandwich, because what's in the middle is the meat, right? So if you got an angle sandwich, you got an angle and sandwich between 2 sides. And if you got a side sandwich, you got a side sandwich between 2 angles. So if you know that this angle and that angle are congruent, and that this side and that side are congruent, you know that this angle and that angle are congruent, you've got an angle, side, angle. You can also use angle, angle, side, AAS, and it could be SAA, but as long as it's an angle, and a side, whether you look at it forwards or backwards, you're good. So you could have this angle and that angle, this angle and that angle, angle, angle. The next thing must be a side, angle, angle, side. You can also use hypotenuse leg, but this only works with a right triangle. You got to have that 90 degrees. Okay, if you have that 90 degrees, then you can use the hypotenuse leg. Okay, the hypotenuse and any leg of a right triangle. So the hypotenuse would be this thing, and then a leg would be like this piece. Now that's the only way that something called angle side side can work. And we call it hypotenuse leg, we don't call it angle side side. The one combination of ways to prove a triangle are congruent that does not work is angle side side. That's a no-no, because you can't write that all over your paper, okay? So the one that makes the bad word is the one that doesn't work. Unless it's in a 90-degree right triangle, then you could do what we call angle side side. But we don't call it angle side side because that's a naughty word. We call it the hypotenuse and a leg. The hypotenuse and a leg. The hypotenuse is the one that is opposite the 90-degree angle. So we cut the angle part out, thus omitting the bad wordy part. So anything but angle side side, unless 90 degrees. All right, reasons sides are congruent. They tell you. Do not assume it just by looking at it. The definition of a midpoint. Okay, the midpoint would say that either side is congruent. Or the reflexive property, if they are connected, right? So like if I do this triangle connected to that triangle, this side is itself. So it's the reflexive property, like a reflection. So you are yourself. You're congruent to you. Okay. So if it's the same, it's one side being used in 2 triangles, you know they're congruent. So they either tell you it's a midpoint or it's reflexive. Angles, they tell you. That's the easiest. They're vertical. Alternate interior angles, alternate exterior angles, corresponding angles. Okay, but you must have the parallel lines. Right? But all of those angle relationships we learned about parallel lines, those are going to come into play again. We're never going to lose those. Or the definition of an angle bisector. Bi is 2, sector is cut. Cut it into 2 equal pieces. That's just like a midpoint. Cuts the line into 2 equal pieces. Or CPCTC. So if they say if triangle ABC is congruent to DEF, then we know all of these parts. Right? We know that AB is congruent to DE. AB, DE. We know that BC is congruent to EF. BC, EF. And we know that CA is congruent to FD. CA, FD. We know that angle A is congruent to angle D. Angle A is congruent to angle D. We know angle B is congruent to angle E. Oops, forgot my angle symbol. B, E. And we know angle C is congruent to angle F. CPCTC. Corresponding parts of congruent triangles are congruent. So that's for your reference. That's how we're going to prove triangles are congruent. Let's go over it again. Okay, we're going to use just SSS, side, and side angle side, SAS. If corresponding angles and sides of two triangles are congruent, then the triangles are congruent. However, you can prove triangles are congruent using smaller pieces. You don't have to get CPCTC. You don't have to show that everything is congruent to everything. If you can show that sum is congruent to sum, then you get to go all the way up to everything. 2 ways of sum, side, 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 angle, side. If 3 sides of one triangle are congruent to 3 sides of another triangle, then the triangles are congruent. And this would follow that because the side is related to the angle. Okay, so if it's a congruent length right here, it would be made by a congruent angle right here. That's how it gets us to CPCTC. But we only have to show that all the sides are the same, then we can follow that all the angles are the same. So if AB is congruent to DE and BC is congruent to EF and AC is congruent to, I started with A, so I got to go DF, then triangle ABC is congruent to triangle DEF. The places have to match up. I can't say AC is congruent to FD. We should, because the angle, like where the angle is, A and D need to match up, and C and F need to match up. Side angle side, SAS. If 2 sides and the included angle, this is an angle sandwich, of one triangle are congruent to 2 sides and include an angle of another triangle, then the 2 triangles are congruent. Just went over those on the reference sheet. Boom, here it is again. You got side, side, angle, 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 and then side, side. So if AB is congruent to DE, and if angle B is congruent to angle E, and if BC is congruent to angle to side EF, then triangle ABC is congruent to triangle DEF. All right, included means the angle between the sides, like in between, included. All right, let's put it to work. State whether they are congruent, and if so, why? So let's look at number 1. Can we say that those triangles are congruent in some way? Well, I see this side, that side. I see an angle in between them, and I see this side and that side. That to me is a yes, because SAS, and now we just have to match them up. So a triangle, let's start with easy, Q, Y, T is congruent to triangle C. So that's the one that was Y was the same as K, and then T was the same as P. Okay, let's try number 2. Now here's that reflexive property. This line is itself in both things, so it is the same as both. So, and then we got this one is to that one, and this one is to that one. So that's 3 sides in both triangles. So that's a yes, because a side, side, side. It's a weird Y. There we go. Because side, side, side. So triangle ABC is congruent to triangle A. Now, here's how we have to match them up, right? A is opposite the side with the 1 mark. So that's going to be the same as C on the other triangle. This is opposite the 2 mark. So A and C in that one. So the letters are going to get weird. Now this one's nice. D and B, easy. So we're going to say C, and then we're going to say D, and then we're going to say A. Because A and C match up. Now, something that tells us interesting things, if this is that we know that this line is perpendicular, or no, sorry, not perpendicular, but parallel to this line, because the alternate interior angles theorem. Okay, because we know angle DCA is the same as angle BAC. So we know those are parallel. And then we could also prove that the other ones are parallel. That thing is called a parallelogram. We'll get to that later. Number 3. Okay, this one gets a little weird because MK is its own little piece. It's the same in both. So can we prove these 2 triangles are the same? So here's what I'm going to do. I'm going to draw a freaking picture of it. I'm going to do J to K. This is M. That's K. That's J. We know this. And we know that. So maybe we have a SAS. So let's look at this triangle. We know this. It was reflexive. And that's L. That's K this time. And that's M this time. Okay. So can we prove that those 2 triangles are congruent? Well, I've got side marked with 2. Oh, sorry, 3. And side marked with 3, a side marked with 1, a side marked with 1, angle and angle, and the angles between them. So I'm going to go yes. That's SAS. Angle's in the middle. So then triangle. Let's do M, K, J is congruent to, I did M first, so that would be K. Triangle. K, and then I went to the skinny one, which would be M in this situation, and then it would be back up to L. J and L would be the same. All right, let's try number 4, and then I'll let you pause and try the last 4 yourself, and then we can come back and see what's going on. Okay. Number 4. Here we go. I've got a side, I've got a side, I've got a side, I've got a side, and I've got an angle. But the angle's not in between them. This would be angle, side, side. That's a no. You can't write that word. Okay, so that's out. No. If it had a 90-degree angle in it, we could switch the name to hypotenuse leg. Now it's okay to say. But nope, not right now. Angle, side, side, no bueno. Okay, I know, but you're like, but there's a side and there's a side and there's an angle between them, but it would have to be this one. And since we don't know those 2 guys, that's not the sandwich, okay? You can't skip a side and make a sandwich. You can't leave the bread floating above the meat. It's got to touch the meat. So if it's not part of the thing that makes the angle, it's not included. All right, give it a pause. Try 5, 6, 7, and 8. Come back. Let's see how they go. Okay, here we go. I see this is one of those weird ones where it is itself. So EF is the same. I got a 1, I got a 1, I got a 2, I got a 2. Side, side, side. Now, name them. Okay, let's go. If I say F, C, E, congruent to triangle, start up at F, go out to D, come back to E. He could have said, I should have had an E in there somewhere. E, there we go. Could have said ECF. You could have said ECF and EDF. You could have said DEF and CEF. Lots of ways to do it, but F needs to match to F, E needs to E, and D and C match to each other. Number 6. Now in here we know that this angle and that angle because of vertical angles. And we know a side. Now we know these are parallel. That means that this angle and that angle are congruent because alternate interior angles, and this angle and that angle are congruent because of alternate interior angles. Now, all three angles, AAA, doesn't give us anything. But angle side angle does, and angle side does, and we got either one of those. So we can pick whatever we want. We could go with angle D, the side DA, and angle A, and being congruent to angle E, the side AE, and angle A. We got a lot of ways, so let's say yes. Go with angle side angle. We haven't done that one yet. And let's see. Triangle D A. Forgot what letter that was. J. D A J. It's congruent to triangle. D was equal E, and then we're gonna go A, and then M. E-A-M. That's how she goes. Ooh, let's practice. Hold on. Come on back now. Very good. You could do side angle side. Okay. But the M needs to match up to the... J needs to match up to M. Yep. And A's need to match up, and D needs to match up. There you go. You could do side angle side. You could do angle side angle. You could do angle side. Those are definitely congruent triangles. Number 7. Let's see. We've got an angle and then a side and then a side. That's a no. Without a 90 degree, we can't switch to hypotenuse leg. And side angle or angle side, no bueno. Okay. We know vertical. We got side angle side. We got side angle side. So yes. SAS. Now we just have to name them. Okay, so which parts match up? Well, we know that C's match up, so we could say C is congruent to C. And then if I go out to the leg that's by the 2, that's an A and an E. And the next one is a B and then a D. Dun, dun, dun. And we are done. That's all you got to do. No angle side side. No angle. But you can have any other combination. It's got to have at least a side in it and some angles in it. So SAS, ASA, AAS, no bad words.